All right, so let's code the access to an array using a pointer. So let's save this file. And notice that I've already pre-declared an array. What I'm going to do now is declare and assign a pointer to that array. Now for this one, I made it a size of 4. For the previous example, I had it at 3, right? So the one that I drew, now we're coding, and okay, I added one more element in there. It's not a big deal. So let's go ahead and do it. So first, we need a pointer, right? Int. Now remember, the reason I chose integer, it's because the data type that's stored or contained is of integer type. So they have to match. And the reason for it is we know if we're going to increment the pointer, it will automatically increment to 4 bytes based on this operating system and this machine. That is because the size of int is 4 bytes. Okay, so let's call this one PTR. It's a variable lowercase. Now make it equal to AR. That's it. That's how you assign the pointer to the array. Now an alternate way to assign this to the array, as I discussed before, is this way. Int asterisk PTR equals ampersand AR, but you have to be specific that will be element 0, the address of element 0. So it's the same thing. Address of element 0 is the name of the array. So that's a major advantage in terms of syntax. So it really simplifies life here a little bit. By just assigning the name of the array is really the first address or the address of the first element within the array. Fine. Now we have the pointer pointing to the first element. As a matter of fact, we can prove that by printing ampersand AR and printing what's inside the pointer. So do that as an exercise. You're going to see that you're going to get the same value. However, we're going to dereference the pointer to access and put data in there. We know the pointer is pointing to the first element, so we might as well put data in that array. So let's go ahead and do that. So now what we're going to do is make dereference the pointer, asterisk PTR is going to be equal, and put a value in there, -3. Now, you need to move the pointer. Otherwise, if you're going to try to write again, let's say you do something like this, asterisk PTR equals 7. Well, you're going to write over your -3, and you're not moving through the array. So you're still at element 0. So in between, you need to increment the pointer. And remember the way I showed it to you is PTR, since it's an address, is going to be equal to the previous PTR plus 1. The 1 is called the offset. So 1 is an offset. And 1 technically means move by 4 bytes since your pointer is of integer type. Okay? If it was a double, it will move by 8 bytes. Remember, we've done size of double versus size of int, right? So, good. So, what if I want to move to the next element? Now, I've shown you an alternate way to do PTR equal PTR plus 1. You could do PTR plus plus. PTR plus plus moves the pointer by 1 again. So, it's the same syntax. So, what you have here can be written this way as well. So, we're going to keep this one, PTR plus plus. Okay? And then we're going to go ahead and do asterisk PTR equals, let's put some data in there, -1, semicolon. So now you know I have 3 elements. Last one, PTR plus plus, okay? And then we're going to go ahead and put some data in there. So dereference. Dereference means use the pointer with an asterisk to put a value, which means you are literally dealing with the value, not the address. When you use the asterisk, you're dealing with the value. And let's put a 6. By the way, before I use the pointer to read the array, let's read the array with an index to prove that indeed these values got stored. So we're going to read the content, the array's content using an index. Just like we did in the previous program, right? And how do we do that? We could do a printf. Okay, so AR0 equals %d, just like we did in the previous program, /n, and that would be AR0. So I want to know at AR0, were we able to put that -3 in there, right? Since the pointer was pointing to the first element. Let's do this 4 times and change the index. So let me copy this. And this will prove that indeed, so let's do this 4 times. The reading, or I'm sorry, the writing using the pointer actually works. Let's do a 1. Now I'm reading using an index. Okay? And then we're going to read using a pointer. So 2, 3, 3 here, and this is 2. It's easy to make a mistake here. This is why we like loops, and it automates the index for us. There you go. So now let's run this program right now just to prove that 3, 7, -1, and 6 were stored in their proper locations using pointers. Okay, so we can see that pointers allow us to have sequential access, and this proves again that the array stores its element in sequential addresses, right? Offset by 4 bytes. So compile and run, and there you have it. So -3, 7, -1, and 6. So everything is good. Now let's go ahead and print this by dereferencing the pointer, right? So the next one, before you do this, reset. So reset the pointer to the beginning of the array. Otherwise, if you do a PTR++ again, you're going to be falling off a cliff. You're going to be outside the realm of where, or the memory allocated for your array. So you need to go back. How do you do this? PTR equals AR. That's the reset. Just like you did here. So you assign it to the first address. You reset it to the first address again. Remember, a pointer is a very movable thing. You can make it point to anything you want. Well, go ahead and make it point to the beginning of the array, because we're going to use PTR++ to move through the array. But first, let's go ahead and dereference the content. So, and that would be AR0, okay, or the first element equals %d /n, and this time I am going to use the pointer dereferencing asterisk PTR. And that would be the first element. Now, remember, if you don't increment the pointer at this stage, you're going to be always pointing at the first element. So using pointers is an extra step than using an index. So you always need to move the pointer around. So PTR++, this increments it by 1. Okay? And we're going to repeat this 4 times. Copy. Except for the PTR++, you don't need to repeat it at the end for the last one. Otherwise, you're going to be pointing at location you don't really need to be in. And then take that one out. Okay? So this allows me to, so this would be element 1, to step through the elements of the array using a pointer by incrementing the actual address stored in that pointer by 4 bytes. Okay? And notice here, I don't need an index. I simply need to dereference that pointer. All right. Well, let's see how this works. And we should get the same results. So compile and run. There you go. We did before, sure enough. So 3, 7, 1, -1, 6 was done by an index. And then starting from here, -3, 7, -1, and 6, these were done using a pointer. So we got the same results, either using an index or using a pointer. And eventually we'll see the advantage of using a pointer versus an index, or an index versus a pointer. That depends on the circumstances you're in and how this code is going to be managed. Okay, so now you understand how pointers work with arrays, and how arrays are arranged so they are a form of data structure where data is stored in consecutive memory locations with an offset based on the size of that data or the nature of the data that it's containing. Okay? The next video, we're going to learn how to do interactive programming with variables, which means you're going to be entering this data that we're just playing with from the keyboard. See you then.